Why can't we just hitch a ride on a comet? Are there veins of ore that we could mine on other worlds? And will there be an internet on Mars connected to Earth? All these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Coyote Casey. Have we found any ore veins on the moon or Mars or other planets? Do these formations exist on them like they do on Earth? Ore veins on Earth are created by various geological processes that seem to be unique to Earth. So a couple of examples are plate tectonics, that we seem to have this sort of floating continents, this crust on top of the mantle. It doesn't look like this is a thing that appears to be on other worlds. Like maybe Mars or Venus had plate tectonics in the past, but they don't seem to have them today. The second thing is to have hydrological processes. So you want to have things like lakes and rivers and vents of water and oceans and things like that that can allow various minerals to accumulate into concentrations. And while we do have, we have lots of that here on Earth, there are only like past historical examples of that on other places like Mars. And then the third thing is that many minerals are created through biological activity. When you think about limestone cliffs, right? You've got this place where the bodies of animals built up over time into giant concentrations where people can mine that out for limestone and things like that. So there aren't direct analogies for what we have on Earth to what we can see across the solar system, but there are definitely concentrations of various metals and other really useful elements on other worlds. So let's talk about the moon first. So the moon is, covered in ancient hardened lava. When you look at the moon, you can see these dark areas, these mare, and these are ancient flows that came out across the surface of the moon. And we know that a lot of that material is rich in elements like titanium and aluminum and iron. And so in many cases, in silicon, like you literally just have to dig up any chunk of the surface of the moon, especially certain places where you can actually see concentrations of titanium in the flows and things like that. And you can sort of concentrate that material to, if you need those kinds of metals. And then the other thing on the moon is that there are these weird formations that are called creep. And that stands for potassium, that's the K, and then rare earth elements, and then phosphorus for the P. And it's believed that these are the places where the magma ocean, when the moon was covered in a magma ocean, these were the final places where the magma existed before it finally solidified. And so if we go to those locations, those creeps, we can try to access those concentrations of those elements. And so those will probably be places where future mining operations on the moon will go. On Mars, we do know that there was the activity of water for long periods of time on the surface of Mars. And so you're going to have hydrothermal vents, which have probably concentrated material. You're going to have ancient lake beds, places where, minerals came out of the water and formed a sediment at the bottom of some ancient lake that you could then harvest up. And so there are going to be places like that. There are also ancient lava flows on the surface of Mars that theoretically you can go and find various concentrations. And in fact, some really great surveys have been done from space by various spacecraft orbiting around Mars. And so there are actually these great mineral maps. And so one of the places, when NASA was choosing the location for, say, Perseverance and Curiosity, they were thinking about what are the kinds of minerals that we may find. And there was a really interesting sort of discovery that was made by one of the rovers recently where it was rolling along and it crunched over a rock, and it turned out that that rock was made of almost pure sulfur. And we see these kinds of formations here on Earth, and it was not expected that you would see these on Mars. And these are probably some ancient hydrothermal vent. And so, sulfur is going to be incredibly useful on the surface of Mars to future explorers, colonists, whatever. And so to see that is to tell you, yeah, you've got a vein of sulfur. that is coming from deeper down in Mars. And so that's a place that you could actually go and mine to get those. So yeah, in general, there are concentrations of various minerals on Mars and the moon, which people will be able to go and find and harvest. Kamar Taylor 2902. Why is it harder to land on the moon than on Mars? Or is it? Actually, it is way harder to land on Mars than it is to land on the moon. And, we joked in the recent Space Bites just about how difficult it's been to land a spacecraft on the moon and how, the track record has not been good for the last several landers, only a few partial successes in a large number of landers. And like the Chinese had a successful landing, and then there was a failure from India and a failure from Japan, and then a partial success from Japan, failure from Israel, partial success from the US. So it's tricky. And yet the moon is the easy place to land compared to Mars. And I think, part of why this is happening is that you're seeing a lot of private spacecraft that are attempting to land on the moon for the first time. And so these spacecraft have just not built up the institutional expertise of developing a lunar lander. And then the various countries that have attempted to land on the moon have not built up that institutional expertise. And so you can't hire somebody who used to work at NASA and designed lunar landers to now work at your private space firm. Nobody in the Western Hemisphere has been building lunar landers, but the Chinese have. And that's been going really well for them. I mean, they have successfully landed Chang'es 1 through 5. I'm not sure how many of those were actually landings on the moon, but they've landed a ton on the moon. And so here's why Mars is harder, which is that on the moon, you don't have an atmosphere, right? And so you can just use a propulsive landing all the way down. And there's no atmosphere, there's no turbulence, there's no heating. You literally just have to calculate the right amount of fuel to use to land at the spot that you want to go. And you have to counteract your orbital velocity. And your orbital velocity is relatively low. You're going about 2.6 kilometers per second around the moon. And that's what you have to counteract to be able to actually land on the moon when you're in orbit. And sort of compare when you're in orbit on Earth, you're going about 7.6 kilometers per second. So it's a lot faster. And so Mars has an atmosphere. And also, when you arrive at Mars, you're taking this interplanetary trajectory where you attempt to essentially enter the atmosphere of Mars directly. And so you're coming in at more like 5 to 6 kilometers per second when you actually enter the atmosphere. And then when you do enter the atmosphere, it is thick enough to cause turbulence and heating. And so it sort of causes a lot of difficulty to your spacecraft, but it's not thick enough that you can use it to slow yourself down, use parachutes, and actually land safely on the surface of Mars like you can on Earth. Like with Earth, you enter the atmosphere, you get slowed down by the heat of the atmosphere, you deploy your parachute. The parachute allows you to just drift gently down to the surface of the Earth. On Venus, you just drop and you land gently on the surface of Venus. In hell, but at least it's easy to land on Venus. But on Mars, you enter the atmosphere of Mars, you deploy a way to slow yourself down, you slow yourself down with like an aeroshell through the atmosphere of Mars, then you deploy your parachutes, and you're still going too fast. And so you need some kind of propulsive landing on top of that. And so with the Viking missions, with the Spirit, Opportunity, with Perseverance, with Curiosity, they all use some kind of propulsive landing to be able to finally finish. Actually, with Spirit and Opportunity, they used airbags, which was pretty cool. So they were able to sort of blow up this airbag and then bounce around on the surface of Mars before they finally came to a stop. And so for the longest time, while there were various successful landers happening on the surface of the moon, from the Soviets, from the Americans, there was just a series of failures attempting to land on the surface of Mars. And they actually called this the galactic ghoul, where like to a certain point, 50% of the spacecraft that have ever been attempted to land on the surface of Mars had failed. But recently, the various nations have been building up that institutional knowledge, that they're learning how to dependably land on the surface of Mars. And so you haven't seen failures from the US. The Chinese were able to stick their first landing on the surface of Mars. So you're seeing people getting better and better at this. And so I think, we're in this really tough time right now where eventually people are going to get a lot better at landing on the surface of the moon. It's going to be when the private landers attempt to land on Mars, then the ghoul will return and start to gobble up spacecraft. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who's already subscribed, and welcome to our recent newcomers. Demand, Tim Carr, Ron, Patrick Hanlon, Russell Avant, and Dreamhawk Lawrence. Join the club at patreon.com/universe today. Snowy fields. Besides Betelgeuse, are there any other possible supernovae that we could see in our lifetime? Absolutely. On average, a star goes supernova in the Milky Way about every 100 years. And we're overdue. The last supernova that's been seen sort of in recorded history was in the 1600s, and that was Tycho's supernova. And since then, there's been no recorded explosions of supernova. The closest one that we know of was the one that went off in the Large Magellanic Cloud back in 1987. And so that is 40 years ago. So that's the most recent one we've seen. And that's like 165,000 light years away, which is very far away. When you think about Betelgeuse, it's like 640 light years away. So that's very close. But there are plenty of potential candidate stars that could go supernova. There's at Carinae, there's a bunch that are much nearer than in the Large Magellanic Cloud. And any one of those could go off. They could happen at any time. I mean, Betelgeuse could have already gone off sometime in the last few hundred years, and we just won't find out about it into the future. There's like a 1 in 4,000 chance that Betelgeuse has already gone off, and we just haven't seen it yet. But like when these things go off, like if Betelgeuse went off, it would be ludicrously bright. I mean, it would increase in brightness by like a factor of 7,000. It would be as bright as the moon in the sky, like a full moon or like a quarter moon. Sort of people argue about how bright it would be, but it would be very bright, visible in the daytime for months. And that would be really impressive. You could read by it. But even like farther away, various supernovae that are 10,000 light years away, they would be very bright. You would see it be one of the brightest stars in the sky, and would be very impressive. So we wait and we hope that we're due. Waka Waka. Could we hitch a ride and core into a long period comet and then make the comet a spacecraft or an observatory? The problem with attempting to hitch a ride with a comet is that you've got to be able to launch your spacecraft and boost it up, increase its velocity to match the velocity of the comet that you're attempting to hitch a ride with. And so once you've done that, once you have expended all of that fuel, then there is no need to hitch a ride because you're now going the exact same speed as the comet. And so then you could be orbiting around the comet and discovering all kinds of things about it. Once you attempted to land on the comet, which is very tricky, we saw the European Space Agency tried that with their Rosetta mission, with their Philae lander. Didn't go so well. It's very hard. It was very tricky to do that with both OSIRIS-REx and with the Hayabusa 2 mission. That the cometary surface is crumbling and cracking, and it's got fissures and things are happening. Like, it's a very dangerous place to try and land a spacecraft. There's no benefit, right, to hitch a ride. And so then, could you make the comet a spacecraft? Yeah, I mean, you've landed on a comet, and there's plenty of things to do to study the comet, but you haven't made it a spacecraft. And you wouldn't want to necessarily make it an observatory because the comet is surrounded by this coma of all of these particles that are outgassing from the surface of the comet. And they're going to be surrounding your spacecraft, and they're going to make it they're going to turn it into a very bad platform to be an observatory. So there is no free ride. Drew D. When humans set up a Mars colony, how will we develop an internet on Mars? That seems pretty important. Can we transfer Earth's internet? So Mars is far away from us. And in terms of light minutes, it's like at the closest point, it's like 4 light minutes away from us. And at the farthest point, it's like 20 light minutes away from us. And so anytime you're attempting to communicate any information to Mars, you have to wait that communications time, the lag, right? The ping times. They're going to kill you. While if you're trying to be playing like CSGO against somebody, you've got to wait 4 minutes for every single packet of information. You're going to be not doing great at the game. So will they have an internet? Absolutely. But you're going to imagine they're going to have a local internet where they're able to communicate in relatively real time on the surface of Mars. They're probably going to have some kind of satellite infrastructure that is allowing them to communicate. And then they're going to be transferring data in bulk back and forth with Earth and maybe other planets in the solar system and the O'Neill colonies and things like that, right? But they're going to have to send these in with, constantly streaming information, but it's going to be on that long delay. And so certain kinds of activities, like, you want to do a Google search on the live information that's back on Earth, you're going to have to wait 4 minutes or 20 minutes for the results of your Google search, right? What is the distance to the moon? And then you wait, and then 20 minutes later, the answer pops up on your computer. For example, say you want to stream a movie, you probably will cache it. So a new movie will be released on Earth, and then it will be transferred to Mars, and then it will be cached on Mars. Anybody who wants to watch the movie is going to watch it from the Mars version. And so it's just that real-time stuff. And so the things that will be infuriating will be like doing real-time chat. Like if you're trying to text message somebody who is interplanetary, you're going to have to wait those, every single message back and forth. You're going to have to wait. It's going to take you an hour to say 3 things back and forth, to be able to do like a video call or, things like a telephone call. All of that's impossible. But you can imagine that there will be these constant data streams that are updated. They're synchronizing the Earth internet with the Mars internet with all of the relevant data that's important. Like Wikipedia will be 4 minutes late on Mars than it is on Earth, or 10 minutes late, right? But they'll be synchronizing and trying to keep everything up to date. So it will be critical, absolutely. And there'll be certain things where you really, it'll feel like you're cut off, right? If there's an emergency and you have to call back to Earth to try and get some instructions to do this thing, you're going to have to wait. Every time you ask a question, you have to wait. Round trip time. You send your message. Your message takes, let's say it takes 10 minutes to get to Earth, and then you wait for their response, and that takes 10 minutes to get back. So now you're looking at double the time, 20 minutes just to get one answer, and it could stretch all the way to almost 40 minutes. So it can be pretty bad. But other times, if it's just you're looking at reference material, things like that, checking up on the news, it'll all feel instantaneous because it's all being sent in bulk between planets. Early rains. Can we communicate with Mars at all if Mars is on the other side of the sun? We can't, no. When Mars gets really close to the sun, it enters this blackout period from the perspective of Earth. And so NASA communication systems lose contact with the spacecraft. And then they wait until Mars has come out the other side of the sun, and then they're able to restore communications. But that's because we're on Earth and we're attempting to communicate with Mars. But you can imagine some future where there's more infrastructure. And so maybe while we aren't able to communicate directly with Mars, we'll have relay stations at the L4, L5 Lagrange points, and they can relay communications. So we send a communication to the relay can then send a communication to Mars, and then it sends back to the relay while we don't have that direct contact with Mars. All right, those were all the questions that we had this week. Thank you, everyone who watched. As you know, we record this show live once a week. There'll be a time for the next upcoming episode here on the channel. I think it's going to be the European time next. So just make sure it'll be at a different time than normal every week. I guess there is no normal. Anyway, thanks. Now I'm going to chat a bit about the upcoming difficulties that I think we're all going to be facing. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Bear Lake Roofing, David Giltinan, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Robach, Sean Sargent, Spiderswap.io, Stephen Fowler Munley, and Vlad Chiplin, who support us at the Master of the Universe level. And all our patrons. All your support means the universe to us. So as many of you know, I'm Canadian, and Universe Today is a Canadian corporation. Many of the employees are Canadian, although we also employ a lot of people in the US. And so we have this very complicated cross-border structure. And so and at the time you're watching this, it may have already begun, but apparently I'm about to go into a trade war with the United States, and this is going to have implications for my company, for my employees, both on the Canadian side of the line as well as the US side of the line. And my hope is that there will be very few disruptions, but my suspicion is that it's going to sort of start off kind of uncomfortable, and then it's probably going to get pretty nasty on both sides as people dig in their heels and attempt to battle each other for a trade war, which is a thing you wouldn't expect friends to do, but here we are. So everything's up for grabs. So I now officially make no guarantees about what happens to the future of the universe today on our channel and the offerings that we make and what we're able to do and provide. It's all uncertain. So I'm going to have to wait and find out. And once I know a better sense of sort of what is expected, what's going to be happening to Canada, how we're going to be responding to the US, then I will get a better sense and modify what we do with the universe today accordingly. So stay tuned. And hopefully this will all go away. But if not, I hope you will be patient as we navigate this. All right, we'll see you next time.